When I was still in elementary school, I wandered these woods almost daily. Me and my friends used to play here and build tree houses. Then there were other gangs of boys who also built tree houses and little shacks of their own. Sometimes we would come here one day and find our tree house damaged and violated. Riled up by this offense, we would then take our cap guns and walkie-talkies and march to their place to confront them. But if we were in bad luck, they were already waiting for us to walk right into a super soaker ambush. Silly boys we were, and little did we know that the forest we played in would be in ruins by the time we would be adults. What I'm getting at here is that while we were completely absorbed by our petty squabbles, we completely overlooked something much bigger going on all around us. Remind you of something? Why this actually happened? Well, I'll talk a little more about that later in this video. For now, I find myself once again in somewhat different surroundings, where we see something else that is often overlooked, and that is the pure joy and meaning one can find in seeing something beautiful come back to life after it had already been written off. In that sense, let's see what we can find at this scrapyard that might be worth bringing back. This cabinet is about 2 meters 40 centimeters in height and super ruggedly built. I think I will buy that. This electrical panel has some cool parts, but I'm too late. Most of the parts have been damaged. This heavy pump here is an awesome find though, and I'm taking that home. These parts look super massive and were probably part of some kind of machine tool, but it might take 10 years before I find an application for them. But down here in the dirt we find an old audio amplifier that someone has put to the side here, and I will buy that as well. In addition, I've also recently gotten my hands on this box here filled with old drill bits and other tools, as well as this mystery box here, and we're going to build something pretty cool from what's inside today. So let's head back to the workshop then. Let's start with something simple then and have a look at this box of rusty tools. Someone had simply put this on the sidewalk in front of his house. It's not like it's a usual thing in Germany for ordinary people to do, just toss their garbage on the streets, but at least in the bigger cities it is commonplace to try to give away certain things before you decide to just throw them away. You will see little boxes and baskets here and there with a little cardboard sign saying zu verschenken, which essentially means for free. Usually you will only find old plates or mugs or stuff like that, but these tools are something special and unusual. I guess they rusted away because of the recent floodings in parts of Germany. Many basements were underwater, and that is what happened here as well. I first want to clean and degrease the tools, and I like inexpensive methods that anyone can use at home. In this case, I'm putting the parts into a pot with almost boiling water with washing powder in it. After a while, I take those parts out of the pot and simply rinse them off. At this point, you can also use a rag or brush to just wipe or brush off some of the loose rust and dirt. After that, I'm preparing a bath of citric acid, as I have done many times before. This type of citric acid can be bought cheaply as a white powder that in many cases is sold as a food ingredient or cleaning agent, for example for removing limestone in bathrooms. After a day or so, I take the parts out of the citric acid, and after rinsing them off with plain water for a second time, I just wipe them off with a towel, and then I use a bit of steel wool to get a better surface finish. You can oil the parts slightly after that if you want. Now, this method won't leave you with super shiny parts, but rather with a certain patina. It comes down to a matter of taste, but I think that this look suits historic tools rather well. Now, some of the parts we found are old auger bits, most of which have a square shape at the end of the shaft, and you can use this in historic hand drills like I showed in earlier videos. We also find some old company logos. This drill, for example, was made by Pharmak, but most of the other tools were all made by a German company called Schlagring, which has brass knuckles as the company logo, and that is also what Schlagring literally translates to, punching ring. There are still drill bits made under that brand name, by the way, today, and there even is a catalog that also tells us what the other parts are. What looks like a drill bit, but without the helical edges, is a mortising bit for drilling or machining slots in wood. in German called Langlochbohrer, meaning long hole drill. These contraptions, apparently a kind of variable diameter drill bit, are called expansive bits for machine use in the catalog. But can you still use some of these tools? Well, in order to test the mortisers properly, I would need an XY table for the drill press, but I don't have one. So all I can show you is just me trying to use them like ordinary drill bits. And as you can see, they cut through that wood like butter. This old drill bit can be used to drill a pretty impressive diameter hole into the wood. But one must first try out at which speed to drill, otherwise the wood and drill will get very hot. But as it seems, these oldies will still be good for something. Remember that poor little amplifier staring at us with its sad, knobless eyes? Well, I guess it was about time somebody gave it some TLC. It's a Pioneer SA410. This model was built around the year 1980 in Japan. With a continuous power output of 2 times 20 watts at 8 ohms, it is not exactly the biggest, most powerful amp out there, but it's an 80s Pioneer, and in my book that means it's worth saving. The source, selector and volume knobs are missing, and the black cover was damaged, probably at the scrapyards. I begin by cleaning front panel and enclosure with baby wipes, and I'm already more hopeful that this might be worth saving indeed. We then also remove the hood and bottom cover and clean the amplifier from the inside. Some rainwater and dirt have apparently found their way in here. With no other obvious physical or electronic damage, let us test this amplifier then. I have now connected these 2 loudspeakers to the outputs of the amplifier, and I also connected this oscilloscope here across the loudspeakers, displaying in dual mode the left and right channel on the output side. What we're now going to do is to feed a 440 Hz sine wave into the auxiliary input, and then we're going to go through the different adjustments, bass, treble, balance, and volume, and see what happens. Okay, so we can hear the sine wave on both loudspeakers. We can also see that they are being amplified at roughly the same amplitude and also in phase, which is good. Now we can go through the different settings here. If we turn down the bass knob, we can see that at least on the lowest setting, the amplitude is lower than in the mid setting. And if we go all the way up, we can see that it's a little higher. And this is essentially what should happen, 440 Hz being a relatively low frequency. We put this back to the mid position, and then we turn on this button here, which is supposed to, well, amplify higher frequencies, but it has almost no effect on this relatively low frequency, which is okay. The balance button also basically does what it's supposed to do. You can weaken or strengthen the left and right channel. Turning the volume button, we already can see that there is a problem here. We hear these scratchy noises, and also, at least on one channel, the signal partially breaking completely down. And this shows us that we have to clean the potentiometer and potentially replace it. So in a next step, I'm pulling the knobs off of the potentiometers, and doing that I can see that these aluminum caps also need new glue, because they are no longer properly attached to those inner plastic cylinders. Now, after unscrewing a few screws, I can pull off the aluminum front panel, and in case you have never done that yourself, yes, this panel is all show, because behind it is actually a much more functionally important steel panel that some of the switches and pods are actually attached to. After removing the nuts holding the potentiometers and also various screws, this second front panel can be removed as well. And behind that we find some more dust and dirt. These older amplifiers are almost always dusty from the inside. No wonder, since they need vent holes in the enclosure so that the warm air from the heatsinks is not trapped inside. This blue tool is a manual desoldering pump, and in combination with an ordinary soldering iron, you can use it to desolder parts, like we do here with the old volume pod. You can now attempt to open the potentiometer, clean the insides and hope that it will work again. You can also attempt to remove oxidation from the wiper contact. However, cleaning cannot restore a physically damaged pot that is simply worn out or scratched. In this case, it did not help, so we needed replacement.
So this is the original volume potentiometer, and you can read some of the values over here. It says 250K, that's 250 kilo ohms, of course. But then it's also a logarithmic potentiometer, not a linear one. And it has two channels, meaning that it's actually two potentiometers that are mechanically coupled together. So if you want to replace one of these, you have to, of course, buy something that has the same resistance value or something close to it, in this case 250K. Then it has to be logarithmic and it has to be a stereo pot, meaning that it has 6, not 3 connections. But it is very hard to find exact replacements for these old pods. This one, for example, has 220K logarithmic stereo, but then this axle here is just much shorter and we will not be able to install it in the amplifier as intended. Also, you can see that the pins have a different shape. Here's another one that I was able to find. In this case, you can even see more clearly that this is basically just the combination of two pods. They are literally just coupled together with this axle here. This one also has 220K because 250K is just a very rare value. It's very hard to find. It's also logarithmic and stereo, and it has an axle that is longer, but well, making something shorter is mostly easier than the other way around. So we can just cut this and then try to fit the knob on here.
Sorry for the following footage. I worked and filmed from my kitchen table because I had caught a cold and wanted to stay home. Though electrically compatible, the pod needed to be customized in various ways to fit into the old amplifier. The hole in the front panel needed to be widened. Then the pins needed to be bent closer together. And then I also needed to file off some material off of those pins so that they could actually be inserted into the board. Then I shortened the axle with a side cutter. At the shop I would have done that with a hacksaw. The edges are then filed off. The inner front panel could now be reattached and the new pod is screwed to the panel before I actually even start soldering, so that the new solder connections are not put under tension. So only after having inserted the pins and fastened the pod to the panel are the pins also soldered in place. In the meantime, I have put it all back together and did my best to bend the damaged cover back into its original shape. And as you can see, the new potentiometer does what it is supposed to do. After looking through some knobs I had still lying around, I also found some at least acceptable replacements for the time being. Ever since the extreme rainfalls and subsequent floodings that we experienced in Germany in 2021, I can't walk past a high-quality pump, even though this one might be better suited for maybe pumping fresh water into a cistern rather than grey water from a basement. This pump was made by the German company Siemens und Hinsch, which was known to both develop and manufacture Seitenkanalpumpen, literal translation side-channel pumps, not to be confused with side-channel air compressors. The 3-phase power cord was cut, the seal of the wiring box sticks out and the cover was installed the wrong way. The little hose that I guess might be for priming the pump is cut off. The massive copper pipe on the inner side was sawed off, and we also still find a bit of hose stuck on a hose barb on the output side. And I'm once again starting by cleaning the pump from the outside, looking for more potential damage. I'm also taking off the fan guard of the 3-phase induction motor and clean the guard beneath. It can be spun by hand without much effort, and that's a first good sign. After cleaning, I open this box and we can find that the stator windings are connected in a Y configuration for what was then 380 volts 3-phase power. I connect a new power cord and close the lid again. I remove the remains of that old outlet hose and also unscrew the bolts on that cast iron flange. Under there we find an old seal that has traces of rust on it. But upon removing the seal entirely, we learn that the heavy casts of the actual pump housing are entirely made from brass to prevent internal rusting of the pump. It appears that it is indeed entirely made from brass and stainless steel parts. A nice surprise. The mating surface is heavily corroded, and the proper way to go about this would be to buy a new part, I guess. But this is a pump from the scrap, and before I spend any more money, I will improvise a solution to test the pump first. The old threads are so corroded that there is no chance to get the copper tube out there by anything but invasive means. I use the fine angle grinder that we repaired in episode 24 to shorten the tube. This episode is number 26, by the way. All older episodes can be found in the video description under this video. I then use a hacksaw to cut some slots in the tube to then punch the remaining parts out of that flange. As I said, I don't want to spend an unnecessary amount of money before I know the pump is okay, so this is all improvised. After wire wheeling the part, I basically coat the damaged threads completely in a thick layer of MS polymer and screw this hose barb that I still had lying around from another pump project into the flange. I then also apply a layer of polymer onto its mating surface, and I just put some sections of a copper ring onto the brass mating surface as spacers before I carefully place the cast iron part on top of it. The good thing about the polymer is that you can just cut it with a knife if you want to remove all this again to install proper parts in the future. While the polymer is drying, I'm preparing some hoses and also a reduction piece for the Gardena system, even though I actually believe that the pump might have a little too much bang for that. For the first test, I'm actually closing that little inlet with a piece of hose that I also shut with some additional polymer. I'm sure the little hose could be used to prime the pump, but for the first test I actually used a watering can to manually fill water into the pump housing via the inlet hose, because without that the pump will not work. And I figured, since I'm kinda wasting water here, I might at least wash the car with it. The outlet hose is a 1/4 inch hose, by the way. People have wondered before why I sometimes use non-metric measurements. Well, that's simply because even in Germany some things like water pipe measurements are still usually in inches. And as expected, it's sucking that limited water supply dry in no time. Next, I install the reduction piece that reduces the hose diameter to, I think, 3/4 inch if I remember correctly, and that should lead to higher pressure, and it certainly does. But it is unpractical to prime the pump via the actual inlet hose, and it can happen that it runs dry if you don't pay attention, so I improvised another contraption. An old cooking pot gets an outlet valve and allows the pump to be primed automatically, even though it takes a moment. So I already mentioned that I found this box here recently. Judging by its outside appearance, one would have to assume that there is a drawing board inside, made by the German company Faber-Castell. Faber-Castell is known to make high-quality pencils, pens and other equipment mostly used by artists. And even though I wouldn't mind finding one of their drawing boards, what was actually inside was even much more of an oddity. So these appear to be advertisements for 1960s office computers of some kind. What we see here are 6 black and white photographs of the same dimensions bonded onto transparent plastic boards. And upon closer inspection of these pictures, we can see that the company was called MDS, which is short for Mohawk Data Sciences. And through some online research, I learned that they were an American computer company that apparently had its biggest success with a computer called MDS 2400, which they started to manufacture in 1969. So that might also be the time these adverts must be from. The company was later sold and does not exist anymore. My greetings still go out to the towns of Herkimer, New York, where the computers were made, and Parsippany, New Jersey, where MDS had their headquarters. Maybe you live nearby, or might otherwise have heard of them. Please leave a comment below. Considering that 50 years have gone by, and the additional fact that there is German writing on some of these American adverts here, I'm pretty sure that these pictures are the last of their kind. But simply storing them somewhere is not going to do any good for anyone. They should be put on display, spreading their irresistible retro charm. And the fact that these pictures are fastened on transparent boards gave me an idea. What if we could light them from behind, and possibly with cool looking effects, even enhancing the natural charm of these pictures? So after going home on the day where I found these old pictures, it came to me like in a flash of inspiration. So the next day I started to gather up all the plywood offcuts I had still lying around somewhere in order to build a sort of light installation with these translucent boards. A piece of plywood made from pine measuring 120 by 60 centimeters will act as the back wall. By mere coincidence, that is the same size that the 6 pictures have when you arrange them in 2 rows. Using a circular saw, I then cut out some side walls from beech plywood that was left over from my camper rebuild. A jigsaw was then used to cut slots into these parts in order to fit them together and to make little holes that wires could lead through. By the way, it is probably noteworthy that both pine and beech are very typical types of wood here in Germany, and you can buy both of these types of plywood in ordinary home improvement stores. See, different types of trees grow in different parts of the world, and here in Germany, for example, spruce is the most abundant kind of construction wood. And if you would go to a store and want to buy beams or what you might call 2x4s, well, those are usually made from spruce here. And while Douglas fir, for example, does grow in Germany and is used to some degree, it only makes up about 2% of Germany's forests, while 25% of it is spruce. The German spruce, however, is in a deep crisis. It was planted as a cheap, quick to grow and easy to harvest wood. But the trees were planted in huge monocultures, even though they are actually not ideally suited for our climate. Long story short, large parts of that population are infested by a type of bark beetle that has led to the utter devastation of entire landscapes here. After we had droughts in the country for 3 consecutive years, the trees were increasingly unable to defend against the beetles. As a result, the landscapes I grew up in as a child have drastically changed. Well, on the bright side, it might be a good thing that these monocultures are vanishing so that actual nature can take hold of these places again. It might just take a long time. But enough with my little rant here about the state of the German forest. Let's get back to our project. And speaking of spruce, after cutting those parts from beech and fastening them on a pine base plate, I'm using little triangular pieces of spruce to glue the two together. See, normally I try not to mix different types of wood in my projects like this, but it sometimes just happens when I work only with materials left over from other bigger jobs. The glue will need a day or so to dry properly, and that's why we will now prepare the electronics side of this project in the meantime. And what we have here are some pieces of Vero board. Then the components in the black enclosures are some bipolar junction transistors, and we also have a bunch of resistors and LEDs, plus a number of blue screw clamps that we will need to fasten various wires to the board. The parts are then inserted into the holes of the Vero board like that, and soldered and properly connected to each other on the bottom side of the board. The purpose of the bipolar transistors is to receive the PWM signals from the Arduino's I/O pins, but allow us to switch much heavier loads, i.e. way more LEDs, than an Arduino can power from its own pins. And the reason for the single LEDs on the board itself is so that I can program the light effects without actually having to connect the board to the light installation. I'm doing that so that I can do this from home because I had caught a cold and didn't want to carry heavy things around all the time. I now begin to install pieces of 12-volt LED strips on the Pine board. There are also programmable LEDs like NeoPixels that you can buy. You won't even need a driver board for those. But these 12-volt strips here are super cheap and I can use them for many practical lighting purposes and usually don't need my LEDs to change their color. That's why these white LED strips are often the most economical choice for me. I then glue 3 sections of these strips into each of the 6 cells and connect them in parallel in groups of 3. The anode sides of the strips are connected together, while the cathode side of each gets an individual wire, leading out of the enclosure via these aviation jacks, just like the common anode wire. The transistors will switch the LED strips via their cathode or minus pole side. Even before the wiring for all segments had been done, I had already started to play around with the LEDs after it had gone dark outside, and after temporarily placing 2 of the pictures onto the 2 cells that were operational at that time. And while it is particularly easy to program simple hard switching effects, a smooth fade in, fade out effect proved to look much more relaxing. And on the next day, after the wiring had been finished, I carefully applied some adhesive onto the wooden case and brought the old photographs in position. And I had already come up with the best possible spot for the new light installation and drilled some holes in the wall where it was supposed to be installed. And I think it really adds a pleasant atmospheric touch to this corner of the workshop, and in my opinion it's a great way for some old pictures to get a little more attention. What do you think about it? Let me know. So I hope you liked this video, and I want to ask you again to please give the video a like if that is the case. That is also the best way to tell me that I should produce more Repair-A-Thons in the future. And if you want to support the channel more actively, please consider becoming a supporter on Patreon. To do that, please visit patreon.com/tpai. See you soon. And here's a little message for those of you who donated to the channel after the last episode. In the meantime, I have sent hundreds of envelopes around the world, and I just wanted to let you know that I sent at least 1 email to every one of you as well. If you didn't get the email, check your spam folder or check if your inbox is full. Out of hundreds of donations, there are unfortunately still about 5 people whose addresses are still missing and who I could not reach. If you live in Europe, including the UK, your envelopes should have arrived by now. If that isn't the case, contact me please.